Hello everyone, welcome back to ECE350. Today we're going to talk about transmission lines. This is chapter 2. So in chapter 2 we're going to talk about transmission line, how you transmit signal from one place to another place. If you see this, it's basically a printed circuit board here. If you see here, there are some of them you can see, recognize them. These are not just for out of region. That's all basically a transmission line, and you can see over here too. So for different purpose. At the end of the chapter, you will understand why this transmission line look like that. Okay. So we're going to talk about transmission line. We're going to talk about how to calculate the parameters of the transmission line. And part 2 of the video for this lecture, I'm going to talk about transmission line modeling. Transmission line could be a two parallel wires, and could be a coaxial cable, could be a microstrip line that you have seen in the previous slides, and could be also optical fiber and waveguides. Optical fiber and waveguide, we're going to talk about them in chapter 8, and transmission of waves we're going to talk about in chapter 7. This chapter we're going to talk about transmission line, basically wired transmission line. And in the sending end, we have the source for the signal, and the receiving end, we have the receiver for the signals. So when a transmission line connects source to the load, source producing your signal and load is receiving it. So over here, the source and source terminal be A prime and receiving terminal B prime, right? So when signal comes from the source end, that's let's say V0 cosine omega t, that signal, and when it reach over here, it will be delayed by this length and the speed of the signal. We're saying that the speed of the signal is speed of the light, which is c is 3 times 10 to the power 8 meter per second. It's the really the highest speed anything can travel. So if it goes on the other side, if I look at the BB prime t, you will see that the signal will be delayed by some time, right? So now if I put back the VAA prime, which is this one over here, to the equations, it looks like this. If we can rearrange that, we can come to this one here. What is the phi 0 over here? This is basically, if you look at the equation, it will be omega L over C, right? So that's the delay. We call it phase delay. There's a delay of the signal on the other side. So let's give an example over here. You have a signal of 1 kilohertz and length is only 5 centimeter. If I put it back here in the equation, so it will be B prime, if I do the math, would be 0.9999 V0. That means there's not much attenuation in the signal on the other side, because there's a frequency is not that high, also length is not that high. It depends on omega L, this factor. This is the constant, right? This is the constant, C is constant, so it depends on omega L. If omega L is a higher value, you get a higher delay at the other side. And if you look at the same time, at the same time, you'll see the signal on the other side is basically attenuated, right? If you look at now, if your L is 20 kilometer now, if you do the same calculation, try to find BB prime, would be 0.91 V0. Now you can look at that. You lost 9% of your signal. You've lost 9% of your signal. Again, we're looking at the same time frame, right? So in that case, your signal attenuated by 9%. If you're sending a 100-volt signal, on the other side you get 91 volts. So you cannot ignore signal attenuation if you have a high frequency signal or longer length. All right. So what is the factor over here? What is the factor you need to consider? As you know that this is your phase shift in the signal, and if we put it back here, this is the factor we're going to talking about, L over lambda. If L over lambda is higher than 0.01 for the transmission line, you have to consider the line attenuation effect. Okay, line effects into the signals. So there's a problem here. We're going to talk about this in the class. So what are the transmission lines? There are different kinds of transmission line out there. These are basically a transmission line used for signal in the like say from one place to another place, wired transmission line. And very common one we use coaxial cable and also two wire cable. So the very common one we use here, and all other it need to be used in different applications, right? Then higher order transmission line, that is basically your fiber optics and guided web guide. And for this transmission line over here, we use them for a specific signal. It's called TEM, transverse electromagnetic. What is that? I have a figure in the next slide, but I'm going to show you this here. If your propagation is this way, this is the your direction of propagation here. All right. Let's say this is your Z. Then let's say this is your two others. Let's say this is your X, this is your Y. So your if your E on this direction over here, your magnetic field is this direction over here, right? Then your direction of propagation on this, that's what I'm saying over here. So direction of propagation, if both signal, electrical and magnetic field, is perpendicular to the direction of propagation. All right. So that's kind of signal use this this kind of transmission line. And what is this guided transmission line over here? That we're going to talk about them in chapter 8. And most of the propagation or transmission we're going to talk about them in chapter 7. So if you look at a coaxial cable, it has a core, and it has a core over here. This is the core, right, in the middle over here, right here, and it has a dielectric materials or insulation around it. Then you have a return path on the outside, right? Return path outside. So if you take a cross-sectional view like this, based on the magnetic field direction, you can see over here, your current is going in. So it's a you can see the back of the arrow, the right-hand roll, you can see that going in. So based on the current, you have magnetic field circulating around, and also your electric field. This is the if the positive current in the core, negative current over here. So the electric field goes from positive to negative. So electric field is radial from the center, and magnetic field is circulating, right? At any point, if you look at any point over here, you see that they're perpendicular to each other. Perpendicular to each other. So magnetic field is radial, and electric field is radial, magnetic field is azimuthal, and propagation into the page. So your signal is going into the page. That means both signal is perpendicular to the direction of propagation, and also they're perpendicular to each other. All right. What is transmission line model? Transmission line is a two-wire line over here. We can model them using 4 components here. We have R resistance, we have L inductance, we have capacitance, and we have conductance. These 4 parameters models your transmission line, and you can model them section by section. You can model them section by section. Okay, you take it one section at a time and model it. So again, all of the parameters, the prime is, say there is a per unit length, ohm per meter, Henry per meter, Siemens per meter, and Faraday per meter. For different wire, let's 3 of them here, coaxial, 2-wire, and parallel line, you have the equation for each of the parameters. So for coaxial cable, A and B basically have inner diameter, inner radius and outer radius, and so on. All the description you can find them into each of the transmission line, what they're talking about. Then RS over here, one of the things I want to point out, RS over here, that RS is basically equations right here. So if you say RS, that equation right here, it depends on your 2 things. It depends on frequency, it depends on mu C, which is conductor permeability, and sigma C, which is conductor conductivity. So sigma is conductivity, mu is permeability, and epsilon is permittivity. So you have to also know that what they mean. All right. So there's a description over here: age, outer radius, inner radius, diameter, and so on. So you have to see that all the description over here for the symbols on the previous slide. And we're going to do this problem in the class. All right, that's all for the first part. We're going to go to the second part and talk about transmission line equations.